It's kind of hard to remember a time when your phone was, well, just a phone, right? But that leap from making simple calls to streaming video wherever you are, that wasn't a slow crawl. It was a full-blown revolution. And today, we're going to dig into the most critical part of that story, the jump from 2G to 3G. This is where the mobile internet as we know it really got its start. Okay, so take a look at this chart. It pretty much explains why engineers back then were probably not sleeping very well. That adoption curve for mobile phones, it's not just steep, it's practically a vertical wall. I mean nothing, and I mean nothing, not the car, not the TV, had ever taken off this fast. This was way more than just a new gadget. It was a total cultural explosion. And the tech underneath it all was scrambling, big time, just to keep its head above water. So that really is the billion-dollar question, isn't it? How on earth do you build a network that can handle millions and then billions of people when the system you're starting with is already bursting at the seams? Well, the answer wasn't to just patch things up. It meant they had to rethink everything, and I mean everything, from the ground up. And that story starts with the very first generation of mobile tech. All right, let's rewind to the beginning. We're talking about the first generation, or 1G. It was amazing for its time. It proved that this whole cellular idea could actually work. But it was all built on analog tech, and it was hitting a wall hard. And it wasn't just one little problem, it was a whole bunch of them piling up at once. Yeah, this right here shows you exactly why 1G was basically a dead end. Because it was analog, your calls were about as private as a postcard. Seriously, anyone with a cheap radio scanner could listen in. The capacity? It was a joke. The very first system in all of New York City could handle a whopping 12 simultaneous calls. 12. And get this, if you traveled to Europe, your fancy new phone was nothing more than a very, very expensive paperweight. It just wasn't sustainable. Something had to change. So, what was the big fix? It was one single monumental shift. Go digital. That's it. By turning voice into a stream of ones and zeros, the second generation, 2G, solved 1G's biggest headaches almost overnight. Boom! Your calls could finally be encrypted, which meant they were secure. The voice quality went from crackly to crystal clear. And, maybe most importantly, this new digital foundation was the first step, the very first taste of mobile data. Okay, so everyone agreed, let's go digital. That was the easy part. The hard part was figuring out how to do it. This kicked off a really fascinating battle between engineers. It created this digital divide with two totally different philosophies on how to share the single most valuable resource in wireless, the airwaves themselves. And this table, well, it pretty much lays out the battle lines. You had these three main standards competing, but the real war was being fought over that top row, multiple access. You see, GSM and another standard called DAMPS, they both used a method called TDMA. But then you had this newcomer, CDMA1, which used something totally different called CDMA. This wasn't some minor technical preference, you guys. This was a fundamental disagreement on the best way to slice up the airwaves, and it created a split that literally defined the mobile world for years. So, how do these two approaches actually work? Let me break it down. Think of TDMA, the one GSM used, like a super disciplined conference call. Everyone is on the same line, but you take turns speaking in these lightning-fast, pre-assigned time slots. It's very polite, very orderly. Now, CDMA, that's more like being at a huge, noisy party. Everybody is talking at the exact same time in the same room, but, and here's the trick, every little group is speaking a completely different language. Your phone is basically engineered to only understand one of those languages, its unique code. And all the other conversations just fade into the background like meaningless noise. Pretty clever, right? So 2G totally nailed the voice problem. It was a huge success. But right as it was becoming the standard, this new beast appeared on the horizon that nobody had planned for, the internet. And 2G was not built for that. This created a brand new bottleneck, and solving it required a really clever, kind of messy workaround, a sort of technical hack that we now call 2.5G. And here's the key thing to get. 2G was designed for one thing, voice calls. Data was just an afterthought. We're talking speeds that were, maybe 19 kilobits per second on a good day. That is literally slower than the screechy dial-up modems people had at home back then. So trying to load a web page, oh, it was brutal. A real mobile internet experience was it was a fantasy. So how do you fix a problem like that without tearing everything down and starting over? Well, engineers got creative and came up with a series of clever hacks. First, there was a small upgrade for a little speed bump. But then came the real game changer, GPRS. This brought us always-on data. What that means is your phone wasn't like a dial-up modem anymore. It could send and receive little chunks of data or packets whenever it needed to. Think email notifications? That was huge. Then finally, Edge came along and squeezed every last drop of performance out of the old 2G system. All these things together, what we call 2.5G, they were like a rickety old bridge, but it was the only bridge that could get us to the mobile internet. But a bridge can only get you across the river. It's not the destination. For the real mobile internet, for what we'd eventually call mobile broadband, you couldn't keep putting band-aids on an old voice network. You needed a revolution. You needed a system that was built from the ground up, with data in its DNA. And that, my friends, was 3G. So the whole point of 3G was to create one global standard for wideband mobile services. See the shift? It wasn't about tacking data onto a voice network anymore. No, this was about building a powerful, high-speed data network that, oh, by the way, could also handle voice calls. And the goal was super ambitious for the time. They were aiming for speeds up to 2 megabits per second. That's fast enough to actually start thinking about things like mobile video and real multimedia. And the magic that made this all possible was an evolution of that party idea we talked about, CDMA. It's called WCDMA, or wideband CDMA. This cube visual is a perfect way to get it. Look, instead of just slicing things up by time or by frequency, WCDMA adds a third dimension, a unique code for every user. This lets you stack tons of users right on top of each other, all using the same slice of time and frequency. The result? A massive jump in both how many people can be on the network and how efficiently it runs. So what did all this new tech actually promise us? Well, for starters, way higher data speeds. Fast enough to make browsing the web on your phone not a chore, and to even watch some early mobile video. It was built on that efficient, always-on data network. And this was a big one. It could handle voice and data at the same time. Remember when a phone call would kill your internet connection? 3G fixed that. This was the beginning of true convergence, and the dream was a single global standard, so you could finally travel without your phone becoming useless. And of course, 3G didn't just stop there. It kept evolving, with a bunch of upgrades we sometimes call 3.5G. The two you might have heard of are HSDPA and HSUPA. Don't worry about the names, it's really simple. HSDPA focused on the downlink, making downloads faster so you could consume content, like watch videos. HSUPA focused on the uplink, making uploads faster so you could create content, like sending photos or making those first kind of grainy video calls. Now, 3G was totally revolutionary, for sure. But its most important legacy might just be the groundwork it laid for what came next. The big decisions, the architectural choices that were made when building 3G, they directly paved the road for the 4G LTE networks we all take for granted today. So let's recap. What were those crucial building blocks from 3G that are still with us? First, that packet-switched core, the always-on internet brain of the network. No more dedicated lines like the old phone system. Second, it introduced wider radio channels, which is like going from a one-lane country road to a multi-lane superhighway for data. And third, it got the ball rolling on all IP networks. The idea that everything, even your voice calls, is just data. These weren't just tweaks. This was the fundamental DNA of the modern mobile internet, coded right into 3G. When you look back, you can see this clear pattern. Each generation was built to fix the last one's biggest problem. 1G just proved it was possible. 2G fixed analog by going digital for voice. 3G was built from the ground up for data, starting this whole convergence thing. And yeah, 4G and 5G have been all about perfecting that. So it really leaves you with one big question, doesn't it? As we start looking ahead to whatever 6G will be, what's the fundamental problem it's going to be built to solve?